We're going to evaluate the limit as x approaches 1 of x cubed plus 6x squared plus 2x minus 9 divided by 3x squared plus 5x minus 8. So let's try to plug in 1 for x to see if this function is continuous at x equals to 1, in which case the limit is the same as the value of the function. We see that the numerator approaches 1 plus 6 plus 2 minus 9, which is 0, and the denominator approaches 3 plus 5 minus 8, which is also 0. So this function has this indeterminate form of 0 over 0 as x equals to 1. To evaluate this limit, we can factor x minus 1 as we did earlier in the course or in Calculus 1. But there's another way to do this, and the other way is called the L'Hopital's rule. So L'Hopital's rule is written in one of two ways, like this, or like this. But we are going to abbreviate it and use this instead, L'H. What does L'Hopital rule say? It says that when we are taking a limit as x approaches a of f of x divided by g of x, and we end up with an indeterminate form, so limit x approaches a of f of x is 0, and limit as x approaches a of g of x is also 0. Now there are other indeterminate forms which we're going to deal with later, but since this indeterminate form in the problem is 0 over 0, we'll consider this first. Then to evaluate this limit, we compute the limit as x approaches a of f prime of x, that is the derivative of the numerator, divided by g prime of x, that's the derivative of the denominator. Note we are not using the quotient rule of differentiation. We're taking the derivative of the numerator, dividing it by the derivative of the denominator, and taking the limit. If this limit equals to L, that is, it's not an indeterminate form, but it is some defined limit L. It could be also infinity or minus infinity. Then the conclusion is the original limit that we're trying to evaluate, that is the limit as x approaches a of f of x divided by a g of x, also equals to L. So let's return to the problem at hand and see how fairly simple it is to evaluate. So we're trying to evaluate the limit as x approaches 1 of x cubed plus 6x squared plus 2x minus 9, and this is divided by 3x squared plus 5x minus 8. We saw that we got the indeterminate form 0 over 0. Whenever we get that, we can apply the L'Hopital's rule. So by L'Hopital's rule, we're going to take the limit as x approaches 1 of the derivative of the numerator, that is 3x squared plus 12x plus 2, divided by the derivative of the denominator, which is 6x plus 5. And note that this function is continuous at x equals 1. There is no indeterminate form. As we plug in 1 for x, we get the value of the function, which is 17 divided by 11. And that is also the original limit. So let's summarize. We wanted to evaluate the limit as x approaches 1 of x cubed plus 6x squared plus 2x minus 9 divided by 3x squared plus 5x minus 8, and by L'Hopital's rule, this limit equals to 17 over 11. For more videos, visit www.mathprepvideos.com.